So today we'll be understanding the second type of resistive transducer, that is the resistance strain gauge. So we understand that with an application of pressure, what we can say, if the if any material having a resistance is stretched or strained, accordingly there will be a change in resistance. So the principle of basically the strain gauge use this principle that with a, that these devices help us in measurement of stress, strain, or you can say pressure by an equivalent measure of change in resistance. So as far as these strain gauges go, they can help us in detection of very small displacements up to an order of the range of 0 to 50 micrometers. Right? Uh, 0 to 50 micrometers. And what we see is that these strain gauges are most of the times used as a part of some another transducer, and we rarely use them as a standalone device. For example, in case of a diaphragm, uh, for pressure measurement, we diaphragm pressure sensors. We will be able to measure the pressure by the amount of displacement of the diaphragm. Fine. So resistance strain gauge, the simple principle is that by application of stress or by compressing or elongating a resistance, there will be a change in resistance as both length as well as the cross-sectional area of the wire will change, and accordingly that measured amount of change in resistance can be reflected as a change in displacement, pressure, strain, stress, etc. Okay? So different type of non-electrical quantities can be measured using a strain gauge. So the nominal values of you can see the nominal values of resistance of which 120, 350,000 ohms. They are very common. Strain gauges of strain gauges are manufactured to various nominal values of resistance. Of these are typically the common ones: 120 ohms or 350 ohm, 1000 ohm resistances. And the maximum change of resistance in a 120 ohm device would be 5 ohm at maximum deflection. Okay? So any deflection can be used for a measurement of 5 ohms. So these are shown here the two typical types of strain gauge, wire type and a foil type. As far as the wire type is concerned, traditionally the wire gauge has been used for major as a resistance gauge. Uh, of a you can this is a simple wire of a nominal cross sectional area, and as strain will be applied to the gauge, the shape of this cross sectional of the resistance wire will distort. Fine. So जैसे कि मैंने पहले भी बताया, the basic equation is R is equal to rho L by A. By changing any of these parameters, we can measure by either by changing length or by the cross sectional area, we will be able to measure the resistance. Right. So as the resistance of this wire will change, proportional to inversely proportional to the cross sectional area and directly proportional to the length, we'll be able to measure the displacement as such. Now, as far as the input output relationship of strain gauge is concerned, that is the transfer function of a strain gauge, is given by the gauge factor, right? Uh, Gauge factor del R by del S. Fine. Del R here signifies the change in resistance. Del S signifies the amount of strain being applied. Fine. So what amount of resistance change to a particular amount of strain being applied, we can accordingly measure, we can accordingly determine the type of strain gauge by knowing its gauge factor. Okay? So the input-output relationship of a strain gauge is expressed by the gauge factor, defined as the change in resistance for a given value of strain, that is, gauge factor is given by del R by del S. Principle of operation simple है, apply the stress, आपका या apply stress or compress it or elongate it. Accordingly, your both length as well as area of the material will change. So in order to measure this, we'll have to understand what the gauge factor is. And for that, we'll be taking this basic equation of resistance, that is R equal to rho L by A, differentiating it on both sides uh, in order to measure the amount of resistance change. dr will be equal to, now considering here what when we are differentiating this, we are considering both L as well as A is changing, as well as resistivity of the material might be affected. So we'll keep for now all the three factors uh, as changing in nature. Fine. लेंथ भी चेंज होगी जब आप कंप्रेस करोगे या elongate करोगे, एरिया क्रॉस सेक्शनल एरिया भी चेंज होगा वायर का, and we will also assume here that rho is also not constant, rho is also changing. So accordingly, after differentiation, we'll be getting dr is equal to rho dl plus, this is your equation, dr is equal to rho dl plus L d rho into a minus 2L dA by a square, simple differentiation. Now dividing this by r on both sides, dr divided by r, this whole quantity divided by r, but we know that r is nothing but rho L by a, that means it is as good as multiplying by a by rho L. Fine. So by mathematical manipulation, you can go through the mathematics. You'll get this equation, dr by r is equal to dl by L plus d rho by rho minus dA by A. We already know that change in cross-sectional area over dA by A, its relationship with respect to Poisson's ratio is given using this formula. Where gamma is nothing but the Poisson's ratio. So we have R differentiating it on both sides, rearrange, dividing by R on both sides, rearranging the terms. You have this equation number, you can say 1, but we know that the relationship between uh, from the stress strain relationships and with respect to Poisson's ratio, dA by A is equal to this term. Substituting that instead of dA by A, uh, doing some manipulations, this is your result. dr by r is equal to dl by L plus d rho by rho plus this all here. Fine. Now as far as this term is concerned here, rho square gamma square into dl by L square, that means dl by L का square है यहाँ पे, dl by L will be very small, so dl by L square will be even much smaller, so we can neglect this term. So we have dr by r equal to this whole, dividing it by dl by L on both sides, you will get dr by r equal to 1 plus 2 gamma plus d rho by rho divided by dl by L. uh, so this term here is known as the Gauss Vector. Mm, we'll differentiate this on both sides. That means By differentiation, dr is equal to we have rho L by 8, R is equal to rho L by 8, differentiating all the terms here while assuming that none of the terms are constant. So आपको पता ही है u by v यहाँ पे, तो u by v का डिफरेंशिएशन क्या है, u dv minus v du divided by v square. So that suggests here rho L का differentiation divided by a square, rho L differentiation of a SA, differentiation of rho L minus rho L SA, differentiation of dA divided by a square. So dr comes out to be a. Now differentiation of rho into L, that gives us rho dl plus L d rho, fine, minus rho L dA divided by a square. Now what I said after this, divide both sides by r, fine. So I am deriving the LHS by r, that means dr divided by r equal to this whole term divided by r, but we know r is equal to rho L by a. So I am dividing the RHS divided by rho L by a. That means ये जो आपका LHS है, it's getting multiplied by a by rho L. A rho dl plus a L d rho minus rho L dA divided by a square. Fine. We are differentiating r equal to rho L by a while assuming that none of the terms here are constant. So dividing then by r on both sides. On the right hand side, what I am doing is I am substituting r equal to rho L by a after the division. That means it's as good as multiplying it by a by rho L. So you can see a और a square यहाँ पे cancel out हो जाएगा. So I have dr divided by r equal to 1 divided by rho L into a rho dl plus a L d rho minus rho L dA divided by a. Or this is as good as saying a rho dl divided by a rho L plus a L d rho divided by a rho L minus rho L dA divided by a rho L. फाइन, तो यहाँ पे ए रो कैंसिल आउट हो जाएगा, यहाँ पे ए एल और ए एल कैंसिल आउट हो गया, यहाँ पे रो एल और रो एल कैंसिल आउट हो गया. So what you are getting is dl by L plus d rho by rho minus dA by A. So this is dr divided by r, dl by L plus d rho by rho minus dA by A. Now what I am saying is that by we know that the relationship between the change in area upon the unit area is given and governed by the Poisson's ratio equation. 1 1 minus gamma dl by L char minus 1. So this equation is known to us for any um, where gamma is nothing but Poisson's ratio. So substituting this value of dA by A in equation number 1, substituting this we get dr by r equal to dl by l plus d rho by rho minus dA by A. ये आपकी इक्वेशन आ गई। अब मैं यहाँ पे बोल रहा हूँ कि dl by l is already small, change in length upon unit length will be already small, so इसका जो square होगा that will be even much smaller, so we can neglect this term. So what we have is dr by r is equal to dl by l plus d rho by rho plus 2 gamma dl by l. Fine. So this is dr by r. Now we actually want to find out the Gauss factor as defined. Gauss factor is the change in resistance over the change over the applied strain. So Gauss factor will be given by dr by r divided by dl by l. So we know already dr by r is what? dl divided by l plus d rho divided by rho plus 2 gamma dl divided by l. इस सब को डिवाइड किया हमने by dl by l. So this says us that the Gauss factor will be equal to 1 plus 2 gamma plus d rho by rho divided by dl divided by l. So this is the Gauss factor, 1 plus 2 rho, 2 gamma plus d rho by rho. Now in case that we know that the change in the resistivity will be either way much smaller or it will be almost zero. So in that case, Gauss factor is approximately defined as 1 plus 2 gamma. So this Gauss factor is dr by r divided by dl by l. That is actually the change in resistance upon the applied strain to the material given by 1 plus 2 gamma, where gamma is the Poisson's ratio. And depending upon a number of factors, the Poisson's ratio depends upon a number of factors of the type of material that we are using. And as suggested, d rho might be tending to 0, so you can actually approximately neglect this term. So this is your output-input relationship of a strain gauge. So the input-output relationship of a strain gauge is expressed by the Gauss factor, and it is defined as the change in resistance for a given value of strain. Strain can be calculated uh, in terms of how much unit can be measured in terms of the change in length upon unit length. So 1 plus 2 gamma, where gamma is the Poisson ratio, is the output-input relationship governing your strain gauge. Now, this is the basic actually idea of a strain gauge, a resistive strain gauge. We have to study different types of resistive strain gauge as well. So today we'll be taking up only one type of strain gauge. Uh, that will be actually the unbounded type. If you bounded type it, that will be for the next discussion. So besides that, there are some other things that you can note down from the notes as well. Some of the most common types of strain gauges that are used, they are advanced or isoelastic, where advanced is a type of alloy as well as isoelastic is a type of alloy. ठीक है? So इनकी different concentration दी गई है. Advanced is an alloy made up of 55% copper and 45% nickel. And in this case, the gauge factor is about 2, while as isoelastic is a type of alloy made up of nickel, chromium, manganese, silicon, molybdenum, iron. It has a gauge factor of 3.5. Semiconductor materials can also be used as strain gauge elements. The semiconductor strain gauges have a very high gauge factor of about 125. So this high gauge factor in case of semiconductors is because of the change in resistance owing to piezoresistive effect. That will actually be seeing when we study piezoelectric transducers as well. In metallic gauges, that are actually the type of gauges that are mostly used, there are two types, the unbounded types and the bonded types. In case of what happens in case of unbounded types are the resistance wires are made up of or about this much diameter 0.025 fixed with some initial tension between two frames that can be moved related to each other. ठीक है, there will be two different frames जिनके बीच में कोई रेजिस्टिव वायर लगा के होगी. इन दोनों फ्रेम्स को हम we can actually apply the pressure, the strain, stress on these frames, and accordingly the resistance of the wire will be changed. That can be measured as that will be measured as a change in resistance, providing an equivalent change of equivalent amount of voltage output. That voltage will be measured to find out what amount of stress or strain was, what amount of stress was actually applied on these plates. Okay? So this initial tension or preload is necessary to avoid buckling under compression. So this here is one type of unbonded. These here both figures are showing unbonded strain gauge. ठीक है? So there are two plates जिनके बीच में actually wires लगा के हैं, and once applying some amount of stress to those plates, an equivalent amount of resistance will change on the wires. Fine. So they can also be flattened out to be represented by a bridge circuit. In both the cases, the bridge circuit representation is shown. Uh, Whereas in case of bonded strain gauges, the resistance wire is made up of uh, the resistance wire different is made up of a form of a grid and cemented structure that's placed between two pieces of thin paper. The factors that are to be considered for making up of a bonded strain gauge, they include filament construction, the material of filament wire, the base carrier material, the cement to be used for bonding these filaments, the lead wire connections, etc. So what we have to do is basically there are now bridge circuits that need to be studied under the strain gauge. Uh, how these we have actually studied already some type of bridge circuits. We'll be studying the basic operation of these bridge circuits and how strain gauge is applied. Strain gauge can be used within those bridge circuits, and how resistance can be calibrated to find out an equivalent amount of voltage output by the change in resistance. So those different types of bridge और ये जो points मैंने यहाँ पे end पे दिखाए, the type of elements that we use, the type of bridge that we'll be using, ballast circuit, strain gauge circuitry, that all will be taken care of in the next session. So this was a basic fundamental basis of the strain gauge. अभी हमने कोई strain gauge की application या strain gauge कैसे use करते हैं वो नहीं देखा. How it's actually implemented in different types of materials, how we can actually calibrate the output and the output voltage with respect to change in resistance, that we'll see in the next session.